Okay, here's part 2. I think I'll do the next parts as like 2 graphs apiece. Okay, so this one is nicely factored for us so that we don't have to go and do anything with that. So I just need to start with my domain. So my domain is all real numbers except x cannot equal positive or negative 2. Do I have any wholes? No, because I don't have a common factor in the numerator and denominator. My roots, the only one I have is 0 here in the denominator. Vertical asymptotes, I have one at x equals negative 2 and x equals positive 2. Tangency and togetherness, well, I don't have a common or a factor that's squared in the numerator or denominator, so there is none there. Horizontal asymptote, well, it's bottom heavy, even though it's not multiplied together. I know that that has a degree of 2 in the denominator, so since it's bottom heavy, it is y equals 0, which means I do not have a slant asymptote. My y-intercept, well, if I have a root that's 0, my y-intercept is 0, 0, because when I plug in 0 for that x, it just takes care of it. Alrighty, so on my number line, I'm going to put my roots, which is at 0, and then my asymptotes, which are at negative 2 and at 2. So if I plug in a negative 3, I'm going to get negative, 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 which is overall negative. Plug in a negative 1, I'm going to get negative, negative, positive, which is positive. Substitute in 1, or like a positive 1, I'm going to get positive, negative, positive, which is negative overall. Substitute in at 3, I'm going to get positive, 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 which is overall positive. And since there is no tangency or togetherness, the fact that this alternates should make sense. You still need to do this, because if you just still need to do it just to make sure for yourself that you don't mess anything up. Plus, having this can really be helpful in actually graphing it. Okay, so we're going to graph it. If you haven't tried to graph it on your own, then I highly, highly suggest that you pause and try to graph it on your own, and then come back and look at what I've done. So I'm going to put in my asymptotes. I have one here at negative 2, and then one at positive 2, and then I have my horizontal asymptote at y equals 0. Sort of messed that a little bit, but I don't think that's going to mess up the graph much. It doesn't really go up there, but I think you know that. I just want to make sure you can see it. It's hard to see stuff on this board sometimes. Alright, then I'm going to go and plot the points that I can plot. And I've got my root, which is at 0. So if you ever wondered if you could cross an asymptote, bam, it's right on that. And then my y-intercept, which is 0. So that, sadly, is the only point that I actually get. I have 3 sections of the graph, so I need to make sure I have at least 1 point in each. And even though I only have 1 point here, I actually know a lot. But I'm going to go ahead and get points in this section of the graph and this section of the graph too. So I'm making my little T-chart here. Maybe my y shouldn't be so crazy so it doesn't go. There we go. So I'm going to pick over here, I'm going to try a negative 3. And so when I plug in negative 3, this is going to give me, look at my little work here, negative 12 over negative 5 times a negative 1. So that just gives me negative 12. Sorry, I thought my signs were wrong. It's supposed to be, yeah, negative 12 over 5, which is close enough. I mean, I know that's just 2 and 2/5, something I can plot. So negative 3, and then negative 2 and 2/5. As long as I know it's a little bit more than 2, I'm good. Then on this side, I will pick a 3. So when I do that, I'm going to get a positive 12 over 1 times 5. So that's a positive 12/5. It doesn't always happen so nicely like that. It's not a super nice fraction, but it's the same thing on either side there. So positive 3, then I go to positive 2 and 2/5, about right there. So I'm not going to connect the dots and make a line, although it kind of looks like I could do that. Think about this, right? From negative infinity to negative 2, the whole thing is negative. So I know that it's going to look something like this. And I know it's also not crossing the asymptote because it's supposed to be negative the whole time. If you're unsure about whether or not it actually looked like this, then you could always plug in, you can, choose another point over here so you can see what the shape is like. But it's going to be something like this. Understand that this is always going to be pointing to, negative infinity or positive infinity in either direction. I would never be pointing at the asymptote, though, because pointing at the asymptote like this would imply that I'm going to be able to go through it, which I can't. Okay? So then there is no tangency or togetherness. So since I'm coming down here, I know I have to start from up here on this side. Right? So it has to come from up here. And then this is weird, right? And I know I'm positive between here and here, and then this is negative. And so it's going to have to come down like this. And the only thing that would really make sense to come through here and make that happen would be to have that point of inflection like that. Okay, so looks kind of like a cubic, but this is way more than that. That's the idea of that point of inflection there. Okay, so since this was positive, this was negative, this is positive here, I have to be coming from up here. It's positive the whole time, so I know it doesn't cross my asymptote. And it's just going to come down and look like this. Okay? So it looks kind of crazy weird, but you have a lot of information from your sign chart and from the other things that you have. Whether you have tangency or togetherness helps you. Any points that you can plot, what is happening and what isn't happening both at the same time can be very helpful. Okay? All right, so let's try this next one. So I need to go ahead and factor. And I'm going to get x times x minus 3 over x plus 4. So my domain is all real numbers except x cannot be negative 4. So x cannot be negative 4. I don't have any holes because I don't have any common factors. And then my roots, got one at 0 and at 3. Vertical asymptotes, x equals negative 4. Tangency and togetherness, I do not have a factor that has an even exponent in the numerator or denominator, so that is none again. This is top-heavy, which means it does not have a horizontal asymptote. So I do have a slant or oblique asymptote, so I would do synthetic division here. You can do long division, but I would do synthetic, and you got to use it with the one that's multiplied out here. So I'm going to take this negative 4. Okay, and here's where we got to pay attention. Move it where I can, right there. My board has had a long day, I think. So I'm going to take the negative 4, and then when I pull the numbers out here, this is the 1 for the x squared, the negative 3 for the x, and then the 0 for the constant. Okay, so even though I don't care about my remainder, you want that on there so you don't think that you're ignoring the negative 3 part. Like, I don't care what happens here. So I bring this down and get 1. So this gives me negative 4 and negative 7. So that means that my slant or oblique asymptote is y equals x minus 7. My y-intercept, when I plug in 0 for x, I get 0. So this is at 0, 0. I'm going to do my little number line. So on here, I'm going to put my roots, which are 0 and 3. And then this is at negative 4. So if I plug in a negative 5, and you could use either one of these to figure this out. I prefer this one, though, because I can just look at the signs and not worry about the numbers. I'm going to get negative, 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 which means overall that's negative. And then between here, let me use a negative 1, so I'd have negative, negative, positive, which is positive. 1 is going to give me positive, negative, positive, which is negative. 4, which is positive, positive, positive. then the first thing on my graph is going to be my asymptotes. So I only have one. On this one though, I'm going to tell you before you graph it, to make sure that you use the, I would change the scale or you're going to be mad at me at the end. And I know in the homework I told you, go ahead and count by ones on X but 2 on Y, and that can make it extra confusing when they don't match. But there was a reason for that too, because some of your roots were so close together. These roots are kind of close together too, but because I know the counting by twos and counting by ones is confusing, and the last thing I want to do is stand up here and mess this up, and because it's been a long day for me too, not just my board. So I'm going to count by 2 on both of them. However you do it, it's fine. It should kind of pretty much look the same, but it will go off the graph by a lot if you only count by ones on the Y. So I'm going to count by 2. Which means that my vertical asymptote at x equals -4, I'm only going over 2, but that's because I'm counting by 2s. And I have to remind myself that at every step or I'm going to plot something wrong. My slant asymptote is y equals x minus 7. Okay, so I'm counting by 2s. So that means that this is 2, 4, 6, and 7 is like right there. And then my slope is 1, so that means I'm going to go up 1, which is, well, let's see, up 2, and over 2, so I can go right there. So I got to go through the middle of these, make sure. Oh, look, I'll just do that. Since it's so fat, that kind of makes my line anyway. Why didn't I think of this all along? There we go. Because it's still, you know, slope of 1 would still be 2 over 2, but I don't know that I would actually get it in the right spots there. So, all right. Maybe make it look a little bit more like a line this way. So there is my, oh, it's still going to go off. Dang it. Okay. Mine went way off on my paper. I thought counting by 2s would be fine. This is going to be good enough to get the idea. It's not, I'm 99% sure it doesn't go off this much on the test. If so, no, actually I know it doesn't because I've already done that. But we'll get the idea here. Okay, so I've got my 2 asymptotes. Then I'm going to plot what I can plot. I have a root at 0. I have a root at 3, but I'm counting by 2s. So I'm reminding you, I'm also reminding myself every time I do anything. My y-intercept was at 0, 0. Okay, so that's all I've really got there. So here's what I know. I know that I have a section of the graph that's right here, right? Which means that this is one section because it's sectioned off by the asymptote. So from here to positive infinity is taken care of, which means from here to negative infinity needs to be taken care of, and I need to decide if it's, you know, up here or down here or what's going on with that. So, okay, sorry, I had to pause, so I have no clue what the last thing is that I just said. But here's where my thought was going, was that I really only have 2 sections. I have this section because this will go from -4 to positive infinity, and then over here will go from negative infinity to the -4. So I know that from negative infinity to -4, it's negative, which tells me it's not happening up here, it's happening down here. Okay, and it's going to go off your graph still, and that's okay. I need a point over here. Okay, so I'm here at -4. I'm going to plug in a -8 and see what happens. So when I plug in -8, I'm going to get, let's see, what I do is get -8 times -8 minus 3, all over -8 plus 4, which is a -4. So this is going to be -8 times -11 divided by 4. I can cancel these out real quick. So this is just going to give me -22. Okay, so -22, which again, like I said, it goes off your graph. It's all good. So I'm going to counting by 2s. -2, 4, 6, 8. And then I know this gets me to -20. -22 is like right here. So my asymptotes, if I continued them, and again, it won't be this battlement test. If I continued these right through my work, and I continued this one down here, then what's happening with my graph is that it is coming up. Oops, it's just coming up like this. And you get as long as you get the right idea of what's happening, it's fine. And so again, from negative infinity to negative 4, it's negative. From negative 4 to 0, it is positive. So from negative 4 to 0, it is positive. I know I have to start up here anyway because I don't have any togetherness. So I'm coming up here, and it's positive. Between 0 and 3, it's negative. So I know it dips down right here. And then from 3 to infinity, it's positive. So it's going to come up something like that. So check your little sign chart. Throw in a point or two if you need to. Extend your graph. This one was not pretty to work on the graph that I gave you, but we're just going to deal with it and move on. Okay, so I'm going to pause this as part 2, and then I will start the next one.